and the complete data structure for ticketing, access control, or online payment. So, and you know, developers are really lazy. So we have checked a couple of these cards, and more than, 75% use default keys. So something like, let's compile it, ship it. And the programmers are not using only the example layouts, they're also using the example keys from the data sheet. So let's do a text to the tag. Now, what's possible? We can do dictionary attacks that speed up this process. We can try this dictionary attack with all possible found keys, and some developers are really smart. They make small variations of the keys. So we can use a dictionary with a smart brute force attack to the text. It's possible. So, and one big problem of the design is I've never seen a logout or a false login counter. So if you reset the tag, you can get access once again. And a delay for a false key does not exist. Normally you would expect with a crypto and a well-designed crypto mechanism, after 4 or 5 false logins, you got a delay about 5 or 6 minutes. But these tags are passive. They don't have a clock or anything. So if you just repower them and make an actual reset of the smart card, you can get access once again. We are also possible to do attacks to the backend. For instance, the memory of the ISO 15693 tag acts like a normal storage. It's nothing more than a small USB drive or something like this. We use, of course, RFDump. It's our software. It could help you to manipulate the data like a hex editor. So you can do SQL injections or other attacks are also possible. Yes, what's happened if we got read-only tags? So we read it with RFDump and put the manipulated one to a new tag. That's read-write. Checksums and some implementations use the UID as a mirror block in the user data. This must be changed, of course. And if the block is encrypted, the sector key must be broken once again. I'm going to skip this. And we have here a possible way how to break into RFID supply chain. We have an event manager, we have information server, middleware. You can also transport exploits to your ERP or CRP systems right into the backend. And one big problem of the most tags is they just have a memory warp. So if you try to read multiple pages, you get a multiplier of this page back. So it appears that you have unlimited space to the tag. So RFDump use, for instance, a tag database to avoid reading over the boundary. But normally, the reading is event-driven. So they start reading up to end of field. And as always, input is unchecked in all implementations we have seen. So this is one small denial of service attack with the C-string. And what we are going to see is we have the production data and the C-string terminated by zeros. Just imagine what's happened if you remove it. You got an unlimited. Now there are some additional ideas. There are patents outside in the US. We are no longer doing binary structures and putting binary structures into RFID tags. We're using XML. And of course, it's also possible. If you just fill your tag with RFDump with opening tags, that's it. Another idea that's going to be supported with RFDump, we call it soft tags. It's an emulation of a complete system. So the backend of RFDump can act like a reader and a writer. We do a serial emulation of an ISO 15693 tag. It's really useful for testing backend and middleware, and it reads backups from real tags and manipulation of any UID, user data, or administrative block is possible. Now, first, before we coming to the e-passports, I would like to show you some demonstration of the new version of RFDump that's going to be released in a it's going to be released in a couple of days. I'm still not with this Microsoft stuff. Okay, we have here the new RFDump. we are going to release, it's a Linux application. So with this Linux application, we are going to ship with the RFDump 1.4 version a VMware image, so everyone can get to his favorite Vista, Microsoft Anyway desktop, download a VMware player, and can get one out of his desktop, this special small Linux version of RFDump. It has some additional features, like my last presentation. You can set up the preferences. You have the cookie. You can now use the cookie also for 14.443 tags. You are able to read a tag at once. If you start scan, it's just getting all data. It identifies the tag ID. You got the MyFair tag, and it starts reading the page until it hits the boundary. After the page is read, you have the possibility to make the manipulation as known with classical RFDump. You have the ASCII. It's something like a hex editor for RFID tags. And you can save the layout and load it into the emulator, change anything you want. And we have this new, really cool new feature. You can make a brute force attack trying to break the MyFair key. And the next version is going to release in this next weekend. Will have the dictionary as well to get the encrypted RFID in the same manner like the unencrypted RFID. Okay, and I see we have half our time. Let's start to another research we have done regarding RFID. I'm just going to turn this off. My first question is, are any Europeans here using one of these nice fancy RFID passports and would like to come to the podium for a demonstration? Okay, I applied for a new passport 2 weeks before the BlackHat, and I got one, so we are going to do this demonstration with my own passport. Let's have a short overview over the e-passports. MRTD, Machine Readable Travel Document, also known as Electronic or e-passport. It's specified by the ICAO. This is the International Civil Aviation Organization. Normally, they are doing specifications, how many noise can come out of an airplane engine, and what's acceptable, and what's the wingspan, and what type of airplanes we have. Now they are trying to make IT security. You can imagine what happened. They decided to make an involvement of a global basis. We have this new e-passport from Germany. The tag is embedded into the cover. After my presentation, you can look in front here. And it's produced by Bundesdruckerei GmbH. It's a company owned by the state. And it stores the passport data and biometric information on an RFID transponder. There are also alternative storage methods like a 2D barcode. So if you don't want to use an RFID, they can use a 2D barcode to store the information on a normal readable page. And it's a common standard for interoperability, and some features are mandatory, others are optional. Here's an example with a 2D barcode and the MRZ. MRZ stands for Machine Readable Zone. And this machine readable zone is the key for the basic identification. We will cover this a little bit later on. So let's come to the machine readable travel document data layout. So they defined also all terms new. So they have now the logical data structure, or called LDS. The data is stored in DGs or data groups, not files like anyone else would call it. We have the data group 1. This data group 1 includes the MRZ information and is mandatory. We have the data group 2. This is holding an image portrait and a biometric template. This is also mandatory right now. And we have optional data groups like the DG3 and DG4 to hold additional fingerprints and iris image. We have the security object data, and we have the EFCOM. It lists what data groups are all existing. All data is stored in bare encoded RSN1, and the data group 4 to data group 2 or 2 to 4 use CBFF. It stands for Common Biometric File Encoding. It is also a public standard. It's ISO 19785. Some features. So normally, any RFID chip, any 14443 transponder has a fixed unique serial number. This number is necessary to do anti-collision if you have more than one transponder in the field. After the first design of the ICAO, I got a lot of pressure from privacy groups. So to prevent tracking of the owner without access control, they decided every time if the passport tag gets activated, he is presenting a new unique identifier. So it's now not truly random, but some type of random. The problem is the ICAO machine-readable travel document specs don't require unique serial numbers. And some countries will generate random serial numbers, others won't. We have passive authentication. This type of passive authentication is mandatory for all passports, and it's the method of proof of the passport, and the files are signed by the issuing country. The inspection system has to verify the hash of the data groups. Each security object data contains individual signatures for each data group, and the EOF SOD is signed itself. The document signer public key from the PKD bilateral channels, and the document signer key can be stored directly on the passport. Useful if the country root certifying authority is publicly known. So this is the structure. So they are building actually hashes over each data group. All these hashes are stored and also hashed in an EF-SOD, and the EF-SOD is signed by the issuing country certification authority. Now we have something more. It's called basic access control. This system is to permit access to the data after the inspection system is authorized. So authorization to the machine-readable zone. To get the data actually out of an RFID passport with basic access control, you need the 9-digit document number. In many countries, it's a issuing authority and the incrementing number. That's the way, like the Netherlands passport get hacked, because they are issuing 5,000 passports per year and just incrementing the number. So they start at some known value and just make a brute force. Then we have the date of birth, and we have the 6-digit expiry date. And the 16 most different bytes of the SAH hash over the MRZ are used as key on the SM for secure messaging. So, by the way, who gave his document number at the check-in at the Caesar's Palace? You imagine what's possible? Now, someone breaks into the computer at the Caesars, get all the document numbers, and can now easy brute force your machine-readable travel document. We have also a method that's called extended access control. This is optional because some countries are not interested to sharing biometric information with others. So it's not standardized, and it's implemented by individual issuers, and it means that the content in the DG3 and DG4 is encrypted and can be only accessed with one of the countries who allowed shared access.